So here we will solve rational inequalities. In the previous lesson we solved polynomial inequalities and we relied on the graph to solve. So here let's also solve them graphically. So first let's make sure that we have a 0 over here. Subtract 4 from both sides, and then we'll get a common denominator. Alright, so let's look at some of the characteristics of the left side. If we were graphing this, we could look for the y-intercept and the x-intercept. So this is review of 2.5 day 1, which was graphing rational functions. So here we get negative 4 and 1/6. 25 over negative 6. This is 0 over 0. Positive 25 over negative 6. We get negative 4 and 1/6. For the x-intercept, find out when the y is 0. Multiply both sides by x minus 6. So we have x-intercept. Let's also look for the vertical asymptote. That's when the denominator is 0. So we have a vertical asymptote at 6 because 6 does not make the numerator 0 also. And then we'll also look at the horizontal asymptote. And this is where we compare the exponents. They are the same, so we take this as the horizontal asymptote. And that allows us to graph so the y-intercept is down here, negative 4 and 1/6, negative 4 and 1/6. The vertical asymptote is at 6. The horizontal asymptote is at y equals negative 2. And the x-intercept is at 12 and a half. So we have a y-intercept, and we can see that's happening. And over here, we have that. So now we can talk about where is the graph above the x-axis. When is the graph greater than 0? And so this is below 0. Here's the 0. So we start at negative 6, at positive 6, and we go to 12.5. So the solution starts at 6 and it goes to 12.5, but we have to include this but not include that. There's no y value here, but there is y value there because it's equal to 0. At 12.5, y equals 0, and that's what we want to happen there. Alright, that's how we do it graphically. Let's take a look at the non-graphic method. And it's non-graphic, it'll be numeric. Here's a vocabulary word. Critical numbers, that's when the numerator is 0 or the denominator is 0. We get the same thing we had over here, 12.5 and 6. We got those numbers over here with the vertical asymptote and the x-intercept. And now we use these numbers and we check between them. So we'll make a table. We have, looking down here at 12.5 and 6. We have to check a number to the left of 6, between 6 and 12.5, and then to the right of 12.5. So if we're looking at this method, we would look at the critical numbers 6 and 12.5, and then we pick a number here, pick a number here, and pick a number here. Let's choose 13, 7, and 0. And then we test 0, 7, and 13 to find out which one is greater or less than 0, and we're going to substitute it into this. Less than 0. Here we're going to have it be greater than 0, and this is going to be less than 0. And if we're looking for the, here we want greater than 0, so that's our solution, and that means 7 is true. That means between these two is the solution. So the solution is between 6 and 12.5. And the problem with this is then we have to check each endpoint of the interval in the original or in this. And if we put a 6 there, we divide by 0. So we know there's nothing there. If you put a 12.5 in here, we know it equals 0. And then that's okay because it says equals 0. So that's how we know whether to use a parenthesis or bracket. Pause the video and try that one. And I guess we could do it both ways. So let's look for the y-intercept. the x-intercept. Multiply both sides by the denominator, and so then we'll just be left with the numerator, and we get negative 7.5. Let's look at the vertical asymptote. The vertical asymptote is when the denominator equals 0. Horizontal asymptote, we compare the exponents. Same exponent, so we take the coefficients. So we have to go to negative 7.5. And that's the x-intercept. We need to go to negative 3 3/4. There's the y-intercept. Vertical asymptote is at negative 4. Horizontal asymptote is at negative 2. And if we didn't know what the graph looked like, we would just plot some more points. That's what it looks like. And then we'll look for the graph, the part of the graph that is greater than 0, and it cannot equal 0. So we don't want to include this x value, because that's where y equals 0. And so we know the solution is from here to here, from negative 7.5 to negative 4. And we'll use parentheses. There is no y value here, and we don't want to include that y value. Okay, if we do it numerically, we look for critical numbers. That's when the numerator is 0, or the denominator is 0, and we are using this. We're going to find numbers to test between these. These are the critical numbers. Then we'll check numbers around them, and we can check 0, negative 5, and negative 8. And we'll check those in a table. Negative 5, negative 8, and 0. If we put this into the original, we have negative 2, negative 5, negative 15 over negative 5 plus 4, and that's going to be positive. Negative 8 is going to be negative, and 0 is negative. So we're looking for the positive, and we see the positive at negative 5, and that means this is where all the solutions are, between these critical numbers. So we know it's going to be between 7.5 and negative 4. If we then check these points, negative 7.5 in here, we know that it equals 0, but we don't want it to equal 0. So that means don't include negative 7.5. And negative 4 is an asymptote, so we don't include that. All right, let's look for how to solve a radical inequality. So we'll go back to looking at a radical equation. And we saw this in this chapter where we want to separate the radicals, and then we can square both sides. Three times the radical times 3, so we get 6 radical. All right, and we want to subtract the 6, and we will subtract the 9, and we'll also add the 5. And then we'll square both sides. This will be 45 plus 45 is 90. Distribute. And we have a quadratic, so we want everything on one side. So we're going to add 180. We're going to subtract 216y. And these are all divisible by 9. We'll divide everything by 9. Factor. Alright, so this is where the equation equals 0, and we want to know when it is greater than 0. So we had this, now we have 5 and 9. And we want to know where the graph is greater than 0. No, greater than 3. So let's check 6, 10, and 1. And going back to the original, when we put a y in here, we know that 6y minus 5 has to be greater than or equal to 0. So y is greater than or equal to 5/6. And we also know from this that 9y plus 19 is greater than or equal to 0. So y is greater than or equal to negative 19 over 9. And that means we can't put a negative in here, and we can't put a negative in here that's less than negative 19 over 9, so we know we have to stick with that. If we're looking at 5/6, we have to be greater than 5/6, and we have to be greater than negative 19 over 9. So that means we really have to be, for both of them to be true, we have to be greater than 5/6. And that means over here, 5/6 is, we can't go below that. We wouldn't want to check a number below that. And so now we check. Let's check 1, 5, 6, 9, 10. At 1, we are looking at the original 9 times 1 plus 19 minus 6 times 1 minus 5, and that is greater than 3. When we put a 5 in, it is equal to 3. When we put a 6 in, it's less than 3. And substitute a 9, and then substitute a 10 in the this expression. So now we see we want it to be greater than 3. So it's greater than 3 occurs right here. So we want this. And greater than 3 occurs right here. So we want that. 9 is the boundary that separates. Here we're going to go below, here it's above 3. So we want this interval and that interval. That means we're going to have 5/6 up to 5. We're going to go from 5/6 up to 5. Now, we want it to be greater than 3, so we don't want to include 5. At 9 it equals 3, so we don't want to include 9. It's going to go to infinity. And should we include 5/6? At 5/6 it will still be greater than 3, and that's why we're going to do that. Pause and try that one. So this tells us, and that's equal to 1 and 5/6. So we know that for this, we need to be greater than 5/6. And for the other one, we have to be greater than -6. We need numbers that work in both, so that means we can't use these. We have to start here and work over. So 1 and 5/6 is going to be the lowest number we can use. And now solve. So let's isolate one of them. This will be 7, and then another 7, so that's 14. And now we'll isolate this. So we're going to go -6y. And we have 49 minus 11. And we're going to get 38. And subtract it over here, and we get 34. So we have 6y squared, 36y squared, and 408, 1156, 196. We're going to, let's go back and make sure that all of these are equal signs. Alright, subtract that to the other side, negative 768. Add this to the other side, and we get 3312. And we can divide everything by 4. Divide everything by 4. Now we can divide everything by 12. So this will be 3. That's 3y squared. And then we'll do the quadratic formula. Negative b to a. We simplify that. It comes down to 64 plus or minus 28 over 6. So we get 15 and 1/3 and 6. Then let's check the table. We know that we can't go below 1 5/6, and we have 6 and then 15 and 1/3 critical numbers. So we want to check a number between these. Let's check 2, and then we'll check 7, and then we'll check 16. So 1 5/6, we get 9.69. And we are looking at when is this minus this greater than or equal to 7. So we want to just look at all the yeses. Well, there's a yes there. Greater than, equal to, it's okay. That's a no. 7 is a yes, and that's greater than 7. That's a yes. So we have a yes here. Include 1 5/6. At 7, that's a yes there. At 2. At 6, we're equal to 7, so we're going to go like that, including 6. At 7, our test number, it's a no, so there's nothing there. At 15 and 1/3, we get a yes, it's equal, another bracket, and then we'll go to infinity because it's a yes there, so we get 1 5/6 up to 6, and then 15 1/3 up to infinity. Okay, and that's it.